This lesson is multiplying radicals. Here we have the first example. So we will multiply the outside number and then multiply the inside number. One more time. Multiply the outside number. So 3 times -4, -12. Now multiply the inside number. 5 times 6 gives me 30. One more time. Outside number and then inside number. So 3 times -4, -12. 5 times 6 gives me 30. So the answer is -12 radical 30, or -12 square root 30. Now this square root 30 cannot be square root, so we leave it alone. Okay, so one more time. Outside number, 3 times -4, -12. 5 times 6 gives me 30. So -12 square root 30. Okay? And we leave this 30 alone because we cannot square root. So we just leave it alone as -12 square root 30. Okay? Next example, so same situations. Multiply the outside number. In this case, there's nothing here, but you know that there is an invisible 1. Same thing here, there is an invisible 1. So 1 times 1 is just an invisible 1. Okay, so one more time. This right here, there's an invisible 1. This right here also has an invisible 1. So 1 times 1 is just a 1 here. Okay, so if there's no number in front, it's a 1. Okay, so now we just multiply the insides. 12 times 5 gives me 60. 1n times another n gives me n squared. Okay, since we are multiplying, so 1 and another one will gives me 2. Okay, next we separate them individually. So this 60 right here, I separate it into 4 and 15. The reason I chose 4 and 15 because 4 can be square root and 15 I cannot, so I leave it alone. Again, there are other number that will give me 60, but I chose 4 and 15 because I can square root of 4, but the 15 I cannot. Okay, so at least one of the number is square root. Okay, and then the n squared I separate it by itself. Next, I separate these two, so square root 4 and square root 15. Okay, next, square root 4 can be into 2. Square root 15 I cannot square root, I leave it alone. One more time. Square root 4 is 2. Square root 15 I cannot, so I leave it alone. Now this square root and this square, they are the same. One more time. This square root and this square, they are the same, so they cancel out. So all I have left is just the n. Okay, and then my final answer will be 2n square root 15. Make sure the 2 and the n are in front. Anything that you cannot square root, put it in the back. Okay, so one more time. I chose 4 and 15 because 4 can be square root, 15 cannot, so I leave it alone. At least one of the number that multiply gives me 60 can be square root. One more time. When you choose a number, make sure one of that can be square root. Okay, and this is the final answer. Make sure the 2 and the n go in front. Anything that cannot be square root or still in this radical form, go in the back. Okay, next example, so same thing. There's nothing right here, so it's just a 1, and there's a 1 right here, so it's just an invisible 1. Now let's multiply them. 4 times 2 gives me 8. Here's a 3, and here's a 4, so 3 plus 4 gives me 7. And why I can do that is because it is the product rule of power. Okay, so product rule, power product rule, so m plus n. Okay, so 3 plus 4 gives me this 7. Okay, so one more time. 4 times 2 gives me 8. This 3 and this 4, 3 plus 4 gives me 7. Based on the product rule, Okay, a power product rule. We can add the powers. Next, we're going to separate them individually. So cube root 8 by itself. Now this 7, we want a group of 3. Why do we want a group of 3? Because of this number right here. This number right here means 3. So I want a group of 3. If this was 4, I want a group of 4. But in our situation, this is 3, so I want a group of 3. So break this 7 into group of 3. Okay, so one more time. This 3 means I want a group of 3. So I'm going to break this up, break this 7 into group of 3. So here's the first group of 3. Here's another group of 3. And then this is my leftover. Why I can do that? Because 3 plus 3 gives me 6. 6 plus 1 gives me 7. Okay, so again, this number means 3. I want to separate this 7 into group of 3. So as you can see, first group of 3, second group of 3, and this one is my leftover, okay, or extra. Okay, and then after that, simplify some more. Cube root of 8, you know it is 2. Okay, why? Because 2 times 2 gives me 4. 4 times 2 gives me 8. So 8 is technically 3 2's. A group of 3 2's, which gives me 8. So cube root of 8 is 2. Again, why is it 2? Because this right here is 3 of 2's. There are 3 2's. Okay, so again, 2 times 2 gives me 4. 4 times 2 gives me 8. So I have 3 2's, a group of 3 2's. Okay, so cube root of 8 will gives me this 2. This 3 and this 3, they will cancel out. I just have this x. This 3 and this 3, they cancel out. I just have this x. This right here I cannot simplify. I leave it alone. One more time. Cube root of 8 is 2. And the reason is there are 3 2's. Okay, there are 3 2's. So that's why it becomes just a 2. And then this 3 and this 3 go away. So I have this x. This 3 and this 3, they cancel. So I have this x. This I cannot cancel or simplify. I leave it alone. And then rewrite this so that it becomes 2x squared cube root x. Okay, so this is the final answer for this example. Okay, next example, same thing, more multiplying. So all we have to do is just distribute. So 5 times 3 gives me 15. 15 times 3 gives me 45. Bring down the plus. 5 times 2 gives me 10. And then square root 15, there's nothing to multiply here except a 1, invisible 1, so it stays as square root 15. One more time, we are just distributing. Okay, so 5 times 3 gives me 15. 15 times 3 gives me 45. 5 times 2 gives me 10. And the square root 15 stays as is because there's no other square root. Okay, next we want to separate this 45 into 9 and 5. The reason I chose 9 and 5 because this square root 9 can be square root. Okay, again, I chose 9 and 5 because 9 can be square root. Okay, so bring down the 15, the 9, and the 5. This over here, there's nothing to do, so I bring it straight down. Bring down this 15, square root 9 is this 3. Where did this 3 came from? Square root 9. Okay, I can't square root the 5, leave it alone. This, there's nothing to do, leave it alone as well. Next, 15 times 3 gives me 45. Bring down the square root 5. This again, there's nothing I can do about the 10 square root 15, so bring it straight down. And this is the final answer because square root 5 and square root 15, they're not the same, so I cannot add them. Again, I can only add or subtract if they have the same number, okay, and the same square and the same radical. Make sure they're the same number and the same radical, okay, and in this case they're not the same, so I leave it alone, and this is our final answer, okay. And here's our last example. So same thing, we're just distributing, multiplying them, okay. So here we go. So 2 times 5 gives me this 10. 3 times 3 gives me this square root 9. 2 times 2 gives me this 4. And then square root 3, square root 4 is here. Now the reason why I didn't make this 12, because I know that this square root 4 can be square root. So I leave it as is. But all I did was I just put them together. So square root 3, square root 4, put them together. Okay. Next, square root 5, square root 5. I mean, this 1, there's a 1 right here. So 1 times 5 gives me this 5. And then this square root 5, square root 3 gives me this square root 15. Okay. Next, 1 times 2 gives me this 2. And then 5. And this 4 as over here, square root 4 and square root 5. Okay. Again, I did not put them together. I did not multiply them because 4 times 5 is 20, but I didn't put them together because I know that square root 4 can be square root. Okay, so one more time, distributive property. 2 times 5 gives me this 10. 3 times 3, they give me this square root 9. 2 times 5 gives me this 10, and then 3, this 3 gives me 9. Okay, next, 2 times 2 gives me this 4. Square root 3, square root 4 is right here. 1 times 5 gives me this 5. 5 times 3 gives me this square root 15. 1 times 2 gives me this 2, and then 5 and 4, I leave it as is. Okay. Next, I will square root what I can. If not, I leave it alone. So bring down the 10. Square root 9 gives me 3. 4, bring it down. This square root 4, which is 2. Square root 3, I cannot, leave it alone. This I cannot square root, I leave it alone. Bring down this 2. Square root 4 become this 2, and then bring down this square root 5. Okay. Next, I clean this up a little bit. So 10 times 3 gives me 30. 4 times 2 gives me 8. This is already done, leave it alone. And then 2 times 2 gives me 4. Okay. And this is our final answer because none of these are the like term. Okay, none of these are like terms, so I cannot add them. So I leave it as is. Okay, so be very careful. One more time, when you multiply this times this, it gives me this over here. So one more time, 2 times 5 gives me 10. 3 times 3, square root 9. 2 times 2 gives me 4. Square root 3, square root 4 is right here. 1 times 5 gives me this 5. Square root 5 times square root 3 gives me square root 15. Okay. 1 times 2 gives me 2. Square root 5 times square root 4 gives me this over here. Okay. Next, square root whatever I can square root. So bring down this 10. Square root 9 is 3. Bring down the 4. Square root 4 is 2. I can't square root the 3. Bring it down. Bring down the 5 square root 15 because I can't do anything else. Bring down this 2. Square root 4 is this 2. And then bring down the square root 5. 10 times 3 gives me 30. 4 times 2 gives me 8. Bring this down because there's nothing you can do. And then 2 times 2 gives me 4. Bring down the square root 5. Now here, if they are the same, you will add them. But they are not the same radical. This is square root 5. This is square root 15. This is square root 3. They are not the same, so I leave it alone. However, if they are the same, then we will add them. Okay, so be very careful when we multiply. Simplify the radicals and add like terms. Okay.